This is a GET problem from the electrical engineering paper for 2022. The problem is stated as follows. In the circuit shown below, the magnitude of the voltage V1 in volts across the 8 kilo ohm resistor is dash, and the answer should be rounded off to the nearest integer. So this is a numerical type 2 marks question, and this is the corresponding circuit. So we can see that there are two dependent sources here. This is one dependent source. So this is a voltage dependent voltage source where the voltage V1 is the voltage drop across this 8 kilo ohm resistance, and this one is a current dependent current source, and the value of this current source I is obtained from the current that flows through this branch. So this is a pretty simple question which uses the basic concepts of Ohm's law and Kirchhoff's voltage law. So let's just look at how we can approach this problem. So if we look at this particular branch, we can find that V1 can be formulated as this current I multiplied by this resistance of 8 kilo ohm. Therefore, V1 is equal to 8 multiplied by I, which implies that I is equal to V1 by 8. Secondly, if we look at this loop, then we can formulate the Kirchhoff's voltage law expression as negative 75 plus 2 multiplied by current I plus point V1 is equal to 0. And so as before, instead of using 8 kilo ohms, I have mentioned it as 8, and then assuming that this current I will come out to be in milliampere. So kilo ohms and milliampere can cancel one another. Same over here also, I have taken 2 multiplied by I. So upon solving for this KVL equation, we find that 2I plus 0.5 V1 should be equal to 75. And then we can substitute the value of I from the first equation because our target is to find out the value for V1. Therefore, substituting V1 by 8 in place of I in this equation, we find that 2 times V1 by 8 plus 0.5 V1 equals to 75. And if we go ahead with the solution, the answer turns out to be 100 volt. So this is an extremely simple problem, and getting 2 marks from these sort of questions is really easy.